In this webinar, we'll focus on the Web of Science search experience, but more precisely on the different enhancements that took place in the platform. So I want to go through a little bit of history, and then we'll go through different elements related to your search experience as a Web of Science user. So when we look at the Web of Science, it's a platform where you have a search engine. And of course, in a search engine, the search experience is really essential to your journey as a user. The few things that I want to mention here. The first element is, for those of you who've been using Web of Science for quite some time, you might have seen that Web of Science has evolved. If we just look at from 2017 to 2020, we worked on different elements, user experience, different elements into the search capabilities, but also different explanations on what we mean by each and every field. The key message I want to convey here is that we've been considering how we can improve your journey as a user, especially for beginners, for people who might have less experience with the platform, or that have less experience with what we call fielded search experience. So that's what we've been focusing on for the past decade or so. So as I mentioned, a few examples here. We moved to a one-box search years ago. We used to have 3 fields available by default. In 2019, we simplified the interface. We also added those field explanations, as you can see here, because we know that some users might not know what a topic is or what organization enhance means and so on. So that's basically related to the structure of the database that you search in the platform. And in 2020, we moved also to an all fields search to help users capture more relevant results in your searches. At the same time, this was the beginning of the enhancement of the search experience, but there's more. We listened to the feedback, the different users, different customers. They spoke, and through a survey, the main message that was that the retrieval should be smarter. And these are few elements, few feedbacks. For instance, someone was quite direct and say, please change your search interface. It is terrible. The search engine should kind of have an autocorrect method. It says no for one spelling mistake, no results for one spelling mistake. Now that AI is very developed, AI search may be added in the future. Input a piece of text, AI recognize it and assess the search. No need to disassemble and combine keywords. Advanced search is not smart enough, not user-friendly enough. Incorporate AI into your systems and allow for natural language support. The search method in the Web of Science does not seem to support the use of regular expressions to search. So these are a few examples of feedbacks. I have to say, we do this type of survey exercise on a regular basis. We ask customers, and of course, search comes back quite often in the top categories we receive feedback on through our surveys. So in the last couple of years, obviously, when you receive such feedback, we understand the needs, and many users, researchers, they clearly expressed their expectations, provide a more intelligent, a smarter search experience within the Web of Science. This new search should leverage the recent advancements in terms of technology. So obviously, we want to enhance that the search experience. Of course, when you ask and survey a community of people, users, you're gonna have different user expectations. And the goal here, we see that some users, they prefer natural language interfaces. You just ask a question in a natural way and you expect some answers. Some people prioritize control. So you want to control what you get as results. And we know that those expectations or preferences, they can change over time, over a career. They can differ from situation to situation, depending on the needs. For instance, if you do a quick search for on literature on a specific topic, or if you something quite rigorous, like on a systematic review, obviously the need would be different. So the key message here is that the approach we adopted was to develop a new search experience that we call the smart search. And we tested this new search experience with relatively limited number of users during a specific period of time. So that's what we call beta phase in product development before releasing it to the general public. So the partners, we call them development partners, they had access for up to 12 months during that testing period. And what we looked at is the fact that we also know how important it is to retain the existing functionality. So when you bring something new, of course, you don't want to remove what was working well. So obviously, we don't want to take any options from users. I mentioned already the smart search. That's the new basic search, and it's aimed at beginners. You will see in the Web of Science, that's how it looks like. You have the smart search, which is the new search. Before, you only had the advanced search. I'll come back to that in a moment. But you will see now that's the smart search, which is quite classic in a search engine. You type some keywords, you ask a question, and you see here directly you can search documents, researchers, affiliations, and more. That's how it looks like. I need to explain the differences between smart search and the advanced search. If we look at the smart search, it will recognize automatically different entities. For instance, an institution name. You'll have a combination between the Boolean operators and semantic. So based on the meaning of the words that you write, you'll have the autocomplete correcting the spelling mistakes. You can search at the same time documents and researchers, so publications and researchers, and it's supporting multi-languages. In the advanced search, which was the classic search, the one that we had for quite some time, it's a search based on fields. It's only using Boolean, so there's no semantic search. You can build queries, quite advanced queries, but that's also one capability and also one difference. You can search, do what we call a cited reference search, which is you want to search for publication that cited a specific work or specific author. And you'll see the documents or publications and researcher searches are split. They're not in the same search. But in the advanced search, you can also search on structure search, like the chemical structure of a compound, for example. So, as I said earlier, the user expectations have changed over time, and we need to balance both needs, right? Both types of needs. The needs for more specific use cases, like search strategy, specific fielded searches for entities, chemical structure searches. You'll find that in the advanced searches. The smart search brings new methods of intelligent searching to the Web of Science, and it's more like easier. It's it's more like easy access to the information. The single search box, as I said earlier, it will allow you to search for whatever entity you're interested in. As I said, an institution name, a journal name, researcher name, and so on. You can type phrases in plain language, like natural languages, rather than using Boolean queries. And you'll be able to find related works, publications, even if they don't match the keywords that you use when you do a topic search in an advanced search. When you do a topic search, by definition, the search will try to find publications that mention the keywords, exactly the keywords that you mentioned. Whereas here in the smart search, we also have what we call the semantic search, which is based on the meanings of the words. And as I said, you'll be able to find documents and researchers together at the same time. So you can find experts and authors, key opinion leaders in a specific field. The search here is multilingual. I remember when visiting different countries, when I asked for a research topic, usually researchers would give me the topic in their own language, which makes sense, like French and so on. In the advanced search, it was the advice was to search on English because you'll have more results, even when the full text is in a different language, because you'll focus on the title and abstract. When it comes to smart search, you can search in your preferred language, and you'll have instant translation of your query and abstract of search results. And these will be available for all the languages that we support in the user interface. I'll show you the list in a moment. For example, English, Arabic, Chinese, Japanese, Korean, Portuguese, Spanish, and so on. Yeah, so I want to explain the smart search here very quickly. I want to explain the basics behind this experience. As I mentioned, you'll have the entity recognition. So if you say University of, and you start writing the name of the institution, you'll have that recognition. So it's like Google search, right? You start writing keywords and you get suggestions based on your the meaning. Multilingual search, I mentioned that already. Semantic search, so you'll retrieve content that are semantically similar beyond the keywords that you wrote. You'll have papers and people in the results, type aheads, and autocorrect. So if you write, if you make a mistake when writing a keyword, for example, and you have transparent results. So you will see either Boolean results, semantic results, or a combination that you can choose based on your preference. You'll see that in the smart search, you can choose to list the Boolean, the semantic, or you want to combine both. In the search results, you will see the documents, typically the publications, but also the researchers. I have to mention, when it comes to semantic, a maximum of 100 semantic results are included in any search. The difference between Boolean and semantic, when it comes to Boolean, it finds the exact matches of the terms that you wrote. So if you write a specific keyword, it will retrieve those publications that mention the keyword. Whereas in the semantic search, it will convert the search into a vector. So that's how the semantic search, and it's what to try to find content that is semantically similar. As I mentioned, you will retrieve publications and researcher at the same time. So the people that contributed to that literature. And again, here it will be a maximum of 100 profiles. For those of you who attended previous sessions, in the Web of Science, we have a distinction between a claimed profile, like with the green check, and an unclaimed profile that doesn't have the green check. A claimed profile is typically a profile that has been that is being managed or claimed by someone, right? Someone who logged in into the platform and manages the profile in terms of publications, the names, peer reviews, and so on. So of course, in the search, you'll be able also to see what we call the co-citation map. This is interesting in a sense that when we cite papers, typically we cite relevant papers, similar papers, right? Papers that are related. So if we look at one publication, I can look at co-citation map, okay? And we can assess the similarity. So we would highlight the top 10 most frequently co-cited papers with the original study. I'm looking at one paper here. Is there any other paper that is frequently cited at the same time as this one? So when I read the literature, when I see a citation for this paper, are there other papers that are cited together with this one? So we see here the top 10. Here's an example. I'm looking at the paper here, and you have papers that commonly cite those. So these are commonly co-cited. This one is cited at the same time as this one. This one is cited at the same time as this one, and so on. It's dynamic, interactive, so you can go back and try to find those papers. And we highlight the top 10, as I mentioned earlier. But you can see, for example, here, you will see 546 co-cited documents as a set of results. How did we do that? So we worked with what we call development partners. The way we do it is as I mentioned in my introduction, we worked and we opened the access for a specific period of time. That's a good way to get feedback. And after some time, so these are some of the, what those developments mean for students and researchers. So few examples here. Semantic discovery helps broaden search results, making it easier to explore related research. Smart search is intuitive, user-friendly, making it easier to search for documents and researchers without requiring complex Boolean queries. Unified discovery feature provides a seamless experience when searching for authors, affiliations, and topics. The auto-suggestion feature helps construct searches faster, especially for new researchers. So that's really the point of building this search, is to respond to those needs. We know that many institutions are evaluating what we call generative AI before releasing those tools to researchers. But I have to make sure that Smart Search is not using any generative and agentic AI. We are relying on established technologies. We are not training any models based on what you put in the platform. We're not training anything. AI use here includes, for example, the vector search. Then that's what we call the semantic search. So we basically transform a string of words into a vector, and we try to find words that are similar, or that mean the same thing, that are quite related. And we use large language models for translation, but we are not creating unique answers for customers. The AI is being leveraged to ease the process of conducting a search and finding relevant results, which only include Web of Science records. Yeah, so these are the few things I wanted to mention here. So we don't train on what you put in the platform. We only use Web of Science records. So talking about peer-reviewed literature. And we use machine learning to support users. So as I said, semantic search, the entity recognition, when you type the name of an institution, an author, or a topic, correcting your potential spelling mistakes, and searching in different languages. So that's what we We have, but I also want to mention a few things about what's coming. A little bit of history. In April 2025, in terms of roadmap, so we included at that time the translated search or simplified Chinese AI-powered type ahead. So, context aware, trying to understand the intent of a user. All databases search, document and researcher search, and semantic search. In July, there was an opt-out also possible, supporting Boolean operators, supporting different languages, introduce the cross-citation map, and the search transparency so that you can choose what you prefer in terms of Boolean, semantic search, or a combination of both. This month, so we released the smart search. Now the admin can set the default search landing page for their institution. They can decide what they want the researchers to use. All languages for multilingual, which was not the case at the beginning. That was only open for the UI languages, those languages that I mentioned earlier: English, Arabic, Chinese, Korean, and so on. But now it's supporting all languages. Type ahead for long sentences. Search transparency to view and edit your query on the summary page on the results list. And some updates in terms of user experience and user interface. I have to mention the classic search is still there, right? It's still maintained. Personally, that's the search that I keep using. So expert users that require, queries that need to be reproduced and so on, and that are structured in a specific way. It's still there. It's not gone. The advanced search is still there. You can still do a fielded search, combine fields here, exclude them, use the Boolean operators, and you can also build your queries, right? Each and every field has a tag, and you can combine the different tags as well in your search query. In terms of search experience, something that you might have noticed that was released last year is the research assistant. So we basically want to go further with this new module or new add-on. And this add-on offers what we call conversational search and more visualizations. In terms of AI, there have been different phases, different waves. The first one, a bit of historical now, automating tasks, recommendations. So we had that, for example, extracting citations, recommending profiles and so on, recommending keywords. But then we had the second wave, which was the generative AI. So that's where you've seen a lot of AI assistants. In the Web of Science, it's called the Web of Science Research Assistant, using contextualized knowledge and using guided workflows. So an example is the research assistant that you find a little bit everywhere, like in the Web of Science. The third wave that we call the AI agents. So you'll see more developments about that, planning different tasks, synthesis of different multiple sources, automating different steps or multi-step processes. And that's what we have, for example, the literature review or what we call the WOS Research Intelligence. That's a new platform. So that's the latest wave when it comes to academic AI. To access the research assistant, it's available within the landing page. It is enabled whenever you can benefit from an institutional subscription. So in your case, might not be activated yet in the sense that your institution might not have subscribed to the research assistant yet. So you see here, for example, you have different tasks. You want to explore a topic, conduct a literature review, or find a journal. So these are what we call agentic AI guides in the Web of Science Research Assistant. So we already had a literature review guided walkthrough, but you need to think of this as literature review flow as the new version 2.0, new technology. So it means that users, they can conduct literature review to optimize queries, customize the scope of their review, define the outputs that would be most useful to the users. You can think about a user working on a research paper, let's say on the impact of climate change on homeless people. In this case, the agent takes the user through the whole flow, the whole multi-step workflow, and then it would help you formulate the query to confirm how far back the user wants to explore in the literature, all the way to provide a detailed summary. So, of course, it's doing all of that while keeping the humans, the users, at the heart of the process, right? So it's really AI in the loop. You are in control of the outputs. So to be clear, this is more about helping researchers or helping you work more efficiently with those AI agents rather than replacing you, because that's the work that you should do as a researcher. The reason I'm highlighting this point is because we're going to hear more and more about responsible AI. And for example, when we talk about responsible AI, you have some principles, and we use those principles that are informed by the academic community. There are some opportunities to discover the content faster, get some insights from large data sets, have some personalized learning when you try to get to know more about a specific topic, improve productivity. But there are some concerns. For example, a bias, hallucination, learning shortcuts, bad actors like paper mills, plagiarism, and so on. But I have to highlight a few things. Here we want to provide trusted solutions, so in a transparent way, together with academic community and responsibly. So if you look at some tools like ChatGPT, what we provide the content on is trusted content. Right, so we're talking about curated academic content. It's not everything on the internet. It's not like Wikipedia, Reddit, and whatever. So we focus on scientific literature, but we're also evaluating, testing, and validating results to minimize risks. So we make sure that customers can benefit from the subscription, the content they subscribe to, and we collaborate with publishers, and we have clear definitions of what we can use AI on, so that we know there is no content or copyright infringement and so on. AI comes with risks and challenges. It's not perfect. So we stay and remain fully committed to our principles of keeping research and integrity at the heart of everything that we do. So that's very, very important. We work with the community, work according to different standards. We have an AI advisory council, work through beta programs. We just don't release the tool without proper testing. And we also have customer forums where we hear more about more from customers. Yeah, so that's really the way we work. AI framework, transparency, ethical use of AI, and safe use of AI. When it comes to Clarivate academic AI, you'll see lots of questions, frequently asked questions. This is public, so you'll have all the answers to these questions. This is public information. You can explore that as well later on. There are other areas or different tools that Clarivate is using and developing to leverage AI. And I will mention a few ones here. So how Web of Sense is leveraging AI technology. So in terms of classic technology, that's basically the advanced search. It's really for intermediate experts on users based on Boolean fielded queries, only Boolean, no AI. You build your query manually. Not very flexible in terms of building your query, but it is optimal if you want precision, reproducibility, and systematic reviews. It's not multilingual. That's where here I recommend using English, that you can search title, abstract, and so on. Visualization is limited to analyze results. Transparency is fully manual. Transparent logic, you can always go back to the search query. Then you have the AI, smart search, beginner to intermediate. That's users base. You can search phrases, keywords, or entities, combination of Boolean plus semantic, using machine learning, semantic search, entity recognition, autocorrect, multilingual support. Very, very high flexibility in terms of query building. It's recognized different entities, as I mentioned earlier, but also the intent of the user. This is quite good for quick discovery, finding related content that you might have missed based on the keywords that you use, for example, in the advanced search. And it's very useful when you want to locate quickly researchers and publications. Supporting multilingual query and abstract translation, the visualization that you can benefit from the search, co-citation map, and analyze results that you already have in the advanced search. And you can toggle, in terms of preference, combine Boolean and semantic, or just focus on Boolean, or just focus on semantic results. Then you have the research assistant. This is for all levels. It's more conversational based, natural language plus guided tasks. We use generative AI, agentic AI, very high flexibility in terms of query building and interpretation, refinement. Very optimal to synthesize literature or explore unknown or unfamiliar topic, generate hypotheses that you can test. You have some analytics, but relatively light. Visualization, you have much more. Topic maps, trend graphs, co-citation networks, co-author network, and benchmarking charts. Also multilingual as a smart search, multilanguage input, and summaries. Transparency, AI would explain the reasoning, and it will let you validate the different steps. So that's how it works. You see different technologies, classic technology, AI, agentic AI. What I want to mention here is the other side of the coin. Retractions and citations to retracted papers are rising. So the point here is that we need to make sure that everyone knows about retractions. And when you do a search or literature review, you want to exclude those papers that got retracted. Different studies here, one from Nature, this one from Retraction Watch, this one from Artificial Intelligence. Papers retracted from scholarly journals each year. You see there was a that retracted. AI models are using material from retracted scientific papers. That's very problematic. The papers that most heavily cite retracted studies. So that was a study on listing the papers that cite papers that got retracted. What you have to keep in mind or remember is that the Web of Science Smart Search and Research Assistant exclude retracted papers from their responses. That's very, very important. So that's what you would do manually when you do advanced search. You would exclude the document type. So you could do the same here, but now by default in the Web of Science Smart Search and Research Assistant, the retracted papers are excluded. What's the point in all of this? When it comes to search, it's not what we call one size fits all. Really depends. right, on what you're trying to do, who you are, the experience you have with the Web of Science. But the point I want to make here is that you need to select a pathway that is based on your searching criteria and what you try to achieve. For the smart search, really for beginners, it supports natural language. Multilingual provides a list of documents and researcher profiles with analysis, visual features, use cases. This is good for quick discovery, locating papers, and other. Research assistant, quite interesting, very powerful to explore an unfamiliar topic. You get a nice summary with the sources, the references, synthesize the literature, and suggest journals. This is good for everyone, all levels, supporting multilanguages. It's providing guided tasks, and it's of a conversational type. Then you have the advanced search. The advanced search for experts, for advanced users, but it's quite precise and very helpful when you want to reproduce queries, when you want to conduct a systematic review. Supporting English, because as I said, you would need to put your keywords in English, and that will search in the title abstract of the papers. The advanced search is using precise syntax and operators, and it would provide a list of documents with different analysis. So this is, in a nutshell, what I wanted to mention today in today's session about the search experience. As usual, of course, if you have questions, we have a support 24/7. You'll get a first response within 24 hours. You can always contact this email address when you're stuck on the Web of Science. If you have any questions, feel free to reach out to the support team. Before showing you very quickly in the Web of Science how it looks like, I want to check quickly if we have any questions in the chat. Okay, in the chat there was no question. Okay, 2 questions. For the co-citation map, how the top 10 related papers are selected? Is there a minimum citation for the papers to be considered, or they are selected regardless of the number of citations? No. If you go back to my slide where I have the co-citation map, it's the top 10 frequently co-cited, right? So here in this visualization, you'll see we highlight the top 10. These are the top 10 most frequently co-cited papers. So what we know is that this paper is very often cited at the same time as those papers, or it's just a frequency calculation. So these are the top 10. Of course, if you want to go further, you would have the full list of co-cited documents, but here that's really the top 10. So for this one, it has 546 co-cited documents. Okay, so other documents that are commonly cited with that paper of interest, the paper we were looking at. But the ones that are frequently co-cited, the top 10, are these ones. It's just those that have the highest frequency of co-citation. I think, okay, the other questions was, the answer is in this slide, right? It was the last slide. I'll read the question. It depends on what you want to do. So the question is, you mentioned that even with semantic and updated Boolean search, you still sometimes use the classical one. Yes. Could you please further elaborate on which case the last one can be more effective? Really depends on what you're trying to do. So when you do something that need to be reproduced and you want to do a systematic review, literature review, right? This is quite precise. If you want to get a quick start on the literature, I would use the smart search. This is quick discovery. You say, okay, who's active at the top authors, top institutions I would probably go for this one. Then research, as in this is more like a conversational based search. But it is also quite interesting if you want to synthesize literature, you want to find journals for your manuscript, you want to explore an unfamiliar topic. So this question was asked a few minutes ago. So this is the answer to this question. Okay, so there is another question about the use of ChatGPT. So the question is the following. I have a question a bit out of subject. I'm a second year PhD student. I use ChatGPT to help me structure my Boolean equation for WOS. Would that be a problem when I want to submit my article for peer review? I mean, the search query, you can actually get the link, and in your message, you would say, here is how I built my own search query when I search for the literature in the Web of Science. You could be more transparent in saying, these are the keywords that I thought of, and I asked large language models in ChatGPT to suggest other keywords. Those keywords are the following. These are the ones that were suggested, and I decided to keep those. Maybe some keywords were off topic, and then I build my query. Here is the query that I'm using in the Web of Science, and here is even the URL if you want to open that search query directly in the Web of Science so that we can reproduce your search query. So let me show you how it looks like in the Web of Science. So as I said, in the Web of Science, if you go Web of Science, the landing page now is the smart search. I can decide to opt out and say, you know what, I don't want the smart search. I just want the search, which is the advanced search and the research assistant. Okay. But I can go back and say, I want to try the new search. The new search is the smart search, right? So I can search document researchers, affiliations, and more. For instance, I don't know, I'd say I'm interested in King Saud University, either King Saud University, all right? So this is an affiliation. I could search King Saud University as a topic, right? And now we did a search, and he understood that it was an affiliation. It find the related papers and so on. I could do something different. I could say, I don't know. And it also, you see, suggested some journals that contain King Saud University. So these are university journals published by this university. I could say Moroccan Journal of Chemistry. So that's another name of a journal. All right. I could say Scientometrics. That's an interesting one because Scientometrics is a topic, but it's also the name of a journal, right? So you see, it recognizes different types of entities. One example that I usually use is the ascorbic acid, for example. So you see ascorbic acid, that's vitamin C. It already it suggests some keywords. So what am I interested in? So, and I'll say, and immunity. All right. So that's what I'm interested in. In research, and as I said, it provides documents up to 100 profiles. So if I want to see the files, okay, they're sorted by documents. These are claimed profiles. This one has been claimed in 2016. Well, I mean, the ID was created in 2016, claimed a little bit later when we released the profile management here in the Web of Science. So this is on the researchers. I can have a look at the documents, right? This one got cited 2 times. I'm interested in the documents, the publications that are co-cited, commonly cited with this one. So let's have a look. I see the top 10. So these are commonly cited with this paper I'm interested in by Khalid, 2023. Okay. But there are more. If I want more, I would find 138 co-cited documents with the paper that I was looking at earlier. So that's how I went quickly. Then I can see the researcher profiles. I can do some analysis. We do have some analytics here. trends and so on. You can decide what you want. We want to combine semantic and Boolean, or if I'm interested in just Boolean, okay, so I'm interested in papers that contain the keywords ascorbic acid and immunity. So we went from 500 plus to 477, right? So this one is more strict in the sense that this paper, okay, contains the keywords that I was interested in. Or I could say I want semantic up to 100, as I mentioned earlier, or I can combine if I want. Okay. And if I look at this one, now let's say this one also contains the keywords I was interested in. So that's basically the smart search, right? You can write in those different languages that are multi-languages, all the languages. Initially, what I mentioned in my presentation, when I say the UI languages, I'm referring to those, right? English, Chinese, Portuguese, Korean, Arabic, Russian, and so on, okay? And Spanish. And then you have the advanced search. So that's the one, the search that I commonly use myself, which is the classic search, right? So you type in some keywords, and in here you have control, right? So if I say ascorbic acid and diet, I know that in topic, what we mean by topic is the keywords we search in the title, abstract, keywords plus, and other keywords, right? So here there is no semantic search. I can add fields on publication if I want. I can combine the fields, exclude them, and so on. So here I could say publication year, and I say 2015, 2025. That's good. It's a good one. In the past 10 years, I get a list of publications, and I know that Web of Science, here there is no semantic search. It retrieved this paper because the publication year here is based on my filter, but more importantly, the keywords that I use are the ones that appear in the abstract, okay, and or the title or the other keywords. So here it appears in the title and so on. Then on the research assistant, if you look at, so let me start with a new conversation. So when you use the research assistant, you have some guided tasks. So you have guided tasks, for example, the first one, topic explorer, literature review, final journal. Okay. Here, this is just a process where you go through some different steps. For example, topic explorer, again, I'll use the same topic, ascorbic, the use of ascorbic acid diet, for example. What it does, it will still use the Web of Science, but it will search for the literature, and it will use that literature and will make references to the literature, will identify some topics, right? And with the link to the publications, with the reference documents, so you see, it will tell you the paper that it has used to generate this quick summary. Of course, that's just a quick start. You need to engage more with the literature. You need to dive deeper into those topics. It's suggesting a next step, for example, find review articles, identify top authors, etc. Typically, what you can do manually in the Web of Science Advanced Search, identify top authors, leading institutions, and so on, generate visualizations, mapping your topic, right? It just helps you to do that. If I go for, so if I go for this one and then say, okay, as a follow-up question, I say, what clouds? So something that is quite useful. When I use ascorbic acid diet, there might be some keywords, so it should be words cloud, sorry, put it in the other way. There might be some keywords that I missed, right? By reading those keywords, there might be some keywords that I can include in my search query, in the advanced search, right? Because now I get some suggestions on keywords that I might have missed, okay, or that I need to explore more. Yeah, so you see frequent terms, ascorbic acid, vitamin C, antioxidant, oxidative stress, nutrition, diet, iron, growth, and so on. And then you have another task, which is, again, something that was there already, the find a journal. I give you an example. For example, this one, if I go for, which one was this? This one. I just give a keyword, I get a list of journal. If I go and I give more details, this is my topic. I give the title, the abstract of my manuscript, and I get a list of journals. So that's also something that could be useful. You can interact in different languages. So here we see some examples, some questions in English, one question in Spanish. This one is in Chinese. You see which institutions published the most on COVID in the last 12 months. That's purely analytical. Who are the most cited authors in genetics, right? So that's also something you could ask the assistant. And I was playing with that. For instance, I asked that question as an example in Spanish. So now you see the top researchers in genetics. This one has been cited, highly cited researcher 6 times and so on. I asked this, what are the physical consequences of following a vegan diet? In Spanish, you get the answer, the response in Spanish, and you get the references. And then you always get some follow-up questions, some high-level follow-up questions if you want to see some trends, topic map, top authors, or something more precise in the language that you used when you interacted with the tool. And I think what I've done, I asked the same questions in Arabic. This one here. What are the physical consequences? In the same question in Arabic, and then the same question in French. Okay. So that is quite interesting use case, and of course you can go beyond that if you want. You see the follow-up questions again in the same language. Let me have a look at the chat. Okay, interesting question from Lynn, who says, if you use the research assistant to perform a literature review, do you think this takes away from the analytical capacity that early career scholars, such as PhD candidates, need to develop? By interacting with the literature, for example, new research ideas are developed. You can deepen your analysis and conclusion, etc. How can we make sure that these new features actually support researchers and do not replace key research skills? So the first question, does this take away some analytical capabilities for early career researchers? I would say yes. If you only rely on those tools and say copy paste, and that's not what I recommend you do. Yeah, during my presentation, what I mentioned, and this is actually this slide, right? The Smart Surgery Research Assistant. It's just quick discovery, right? It's more for exploration rather than replacing those skills that are very critical when you build your research career. You want to develop your critical thinking and so on. So my personal answer would be yes, if you only rely on this and say, you know what, this looks good, this is a nice summary, I will copy that without reading it. That would be stupid. What I would do here is, get some ideas from here. We can see some topics, but then I would still explore this literature. 39 papers is very, very easy to manage. I would spend like a few days to go through all these papers, read them. Maybe some of them are not relevant to what you're trying to do, but I would read those papers, trying to understand how they've done the work, their methods, their results, their limitations, and even their ideas for future studies, right? So And that's the interaction with the literature that you refer to, Lynn. So of course, yes. So you just don't copy this and say, I've done a literature review. This is no way a literature review. The same for this one. So this is something that I've done yesterday. You see, this is if you say home, I want to do a literature review. So you have different steps. I can find hotspots, research gaps, and so on. I'll use this one that I used yesterday. I was looking at membranes in nanofiltration. I said, I want to do a literature review. It already identified different topics. It guides me and say, okay, I'm interested in this one. It suggests some keywords. I said, proceed. Now I'm interested in the past 10 years. But this is not a literature review. This is just like the beginning of a literature review, where my advice would be to go and engage with the literature and interact with those papers to understand how those research areas have developed. If there was a research gap here, how did they come up with that idea, and so on. The point I want to make here is the use of AI is interesting, but it also comes with some limitations, with some need for raising awareness, some education, some training. How can we make sure that these new features support researchers? I would say that we need to train to make sure that everyone knows how to make the best use of those tools. And also I have to mention that if you look at those statistics, if you look at this chart, for instance, that I was showing earlier, here, where you have the number of retractions, retracted papers, end of 2022, 2023, there was like a big, at the time of this study, 2024 was not over, but you can get a sense that, as you see, retraction for 2024 are incomplete. It's because of the easiness of writing a paper, generating text, references, literature review, so that sometimes we get nonsense papers that in turn get retracted. So of course, yeah, there's a big need for training. So that's all for the chat. Let me have a look in the question and answers. Okay, there is a question from Nada who said, if we use AI models in conception or organizing our ideas, software detection like authenticate, then that pose issue. We should only have a low percentage. Yeah, so I have to say that those AI detectors or AI generated text detectors are not always precise or accurate, I would say. Again, I wouldn't copy a text from an AI tool. It's just to help me maybe get some ideas. My personal rule is the following: if it's not my text, I don't write it, because everyone has his own style, writing style. So if these are words that I don't even know, I wouldn't even use them, then I wouldn't copy. So I just get the idea, try to get the idea and try to guide you and get some ideas maybe, but then you're the author of your text. I have no idea about the percentage in terms of AI generated AI text detection. I'm not sure. I mean, the publishers would know better, but my advice is to probably avoid that as much as possible. Yeah, there are some personal questions like when the research assistant will be available for a country and so on. I don't have visibility. It really depends on your subscription. And you're several hundred participants today, so it would be difficult for me to answer each one of you. So it really depends on your subscription level. Yeah, so someone who says it's my first time using Web of Science. I have there's a lot of material online on the Web of Science training portal. So Web of Science platform training, you'll find them here in the Web of Science platform training. And then, yeah, Web of Science essential course, that's for 90 minutes. I will share with you the recording of today's session. And I will also share with you the link to the previous webinars, so you can have a look at it as well. Yeah. Yeah, so for those of you who are interested, I mean, this will be for the French speakers. I have a similar session after tomorrow on 20th. I usually announce my webinars on my free newsletter. So, so this one is for the November. So that's for the search experience. I already announced the one for December, so you can have a look at that as well. So after tomorrow, the similar session in French, same time, 20th of November. And next month, we're gonna speak about the highlights of insights in Web of Science for this year, 8th December and 15th December. So let me put that in the chat if you want to have a look at that. And in my newsletter, I'll also share some practical guides. There was some posts about the use of AI. Not sure where it is. It's been, yeah, AI in research, integration of AI tools in research, and so on. So you can have a look at that as well. Thank you very much, everyone. It's been a pleasure. I wish you all the best and take care. Thank you very much. Bye bye.